Hey everyone, in this video, we're going to be going over both smooth and snap turning in VR. In my last video on teleport movement, I got a couple requests for smooth movement in VR. And I think turning is something that's very important that's going to carry over into that. So that's what we're going to do today. This is going to be a pretty straightforward video. But anyways, let's jump right into it. First thing we got to do is create a script. So let's go ahead and create a new mono behavior called player turn and open that up in Visual Studio. Now, first thing we're going to do here is I'm actually going to create a public enum. You saw in the last video, I really like if there's like multiple options for something, I really like putting them in an enum so that you have a nice drop down menu in the inspector. So this is going to be our turn type, and that's going to consist of both snap and smooth. So let's go ahead and create a serialized field here called turn type. And we're going to set that equal to the snap turn is, I think, a good default because it's the most accessible. And then let's go ahead and create another serialized field for snap turn amount. So this is going to be how many degrees our snap turn is going to turn whenever we hit the thumbstick. I like 30 degrees. Some people like 45 degrees. You pick whatever is good for you. And this is going to be a float, of course. And then for our snap turn, we're actually going to need a couple extra numbers because this is an instantaneous movement and our input is going to be our right thumbstick. So what we want is an upper threshold where we're actually going to trigger the value, and then we're going to want a lower threshold for the reset value so that we don't get something like if you're on the threshold, it's going to do a bunch of little jitters and then turn you a bunch of times and stuff like that. So we're going to have a serialized field float snap top threshold, which I'm going to set to 0.8 because again, the value is going to be a 1 to -1. So we're going to want a upper value that's pretty close to the top end, which would be 1. And then for our bottom threshold, we're going to want something close to the bottom. So I'll do 0.1 here. And you can adjust these as is necessary. That's why we're serializing them here. We need a semicolon up there too. And now let's actually take a look at the serialized field. This is going to be float smooth turn amount. And now this is going to be, instead of a degree, it's going to be like the degrees per second that we're going to be turning in our smooth turn. So I like about 60. And then last thing we'll need here is a serialized field. I like using the input action references instead of the input actions themselves because I like having a separate input action map. This is going to be our turn input. And again, if you are a little unfamiliar with the new input system and want a video sort of encapsulating how I use it, I've got a video that I'll link up for that. Let's organize this a little bit. So we'll leave this turn type at the top, but let's create a header here specifically for snap turn values, and then we'll separate out the header for the why is it putting that in there? Smooth turn values, and then we'll go down here and do a header for inputs. All right, so that is our inspector sorted. Let's do our smooth turn first because it's the most straightforward. So I'm going to create a private void smooth turn. And this is going to be pretty straightforward. It's literally 3 lines of code. We're going to need our input. So let's go rotate axis equals turn input dot action dot read value. This is actually going to be a vector2, and we're just going to get the x value. So this is going to be our right thumbstick, but we only need the x-axis from that input. So but we know that the thumbstick itself is going to be a vector2, so that's why we have to read the vector2, but we just need the x value for this. What we're going to need is the actual turn amount that we're going to do this frame. So float, call it turn amount, And this is going to be equal to that rotate axis that we just stored. And then that's going to be our, not our snap turn amount, but our smooth turn amount. And then that needs to be multiplied by time.delta time, because that is going to make it frame rate independent, so that we're not moving 60 degrees every frame. We're moving 60 degrees every second, regardless of frame rate. And then last thing we're going to need is to actually apply the turn. Now, there's something that we're going to need to keep in mind here, and that is if the player is off center in the XR rig. So if I jump over to Unity here and we take a look at our XR origin, we have the origin, the camera offset, and then the main camera within the camera offset. And when we go back to moving our player teleport, and what will be as well our smooth movement, is that this is on the root XR origin. So the XR origin, think of it like the square or the play space that you're in. The play space itself is being moved, but the player can move left, right, forward, backwards, and maybe even up and down, although that doesn't really matter to us, but they can move within their play space, right? So because as well, our snap turn, this is going to be in this same component as well. We don't want to move around the center of the play space. We actually want to move around where the player is. A particular situation might be if a player is up against a wall and we don't have a collider yet, but potentially there's a collider right on the player. What could end up happening is if we're too close to a wall and we turn around the center of the play space, we could actually turn the player into the wall instead of just turning the whole play space around the player, so the player stays locked in place. Now, all that to say, we're going to need to rotate around the camera. So let's actually grab the camera and store it. So I'm just going to store it as a transform. So we're going to store the camera as a transform just because I don't need all the extra camera stuff. And then in our start method, we're going to assign the camera to camera.main.transform. All right, so now that that's stored, we can actually do our turning itself. So this is our transform, our current transform here, dot rotate around. So this is going to allow us to rotate around a specific point. And this is going to be first the axis that we want to rotate around. So that's our camera dot position. Ideally, because we're rotating around the y-axis, we don't really need to worry about the y position. So we can just put in the position regularly. We don't have to take the y component out of it. Next is going to be the axis that we want to rotate around. So we want to be turning around the vertical axis, which is the y-axis. So vector 3 dot up. And then our angle itself, which is going to be that turn amount, which we just calculated. And that should just be it for our smooth turn. Let's actually make it so that we are actually running this function. So I'm going to go ahead and create our update loop, which is just literally going to be a switch statement on the turn type. I call it type or turn type. I just call it type. I am going to rename this to turn type just because I like it. It's a little more specific. So turn type. Going to be case. I'm just going to put the snap turn first. We don't have the method just yet. I'll create it here in a sec. And then we need the smooth. We're going to call the function that we just created. And then I like to do my default case as well. And again, I said this in the last video, but I always like to put this default case when doing switch cases on enums, just to let me know if I was to, I don't know what other turn type there would be, but if you did have one, you would just have this here. And if you don't implement it, you'll see this error message. So you know that why things aren't working is because you haven't implemented this enum type. So let's just go ahead and create this guy. I'll just put here. And there we go. So that's not going to do anything right now, but it's there for us when we're ready for it. So let's go ahead and save this out. Go ahead over to Unity. And first thing we're going to need to do is add this to our component here. So let's do a player turn. We got that script there. I'm going to put it, I'm actually going to move the input action manager up to the top here, just so that it's kind of out of the way and these are next to each other. But we're going to need, first we're testing the smooth movement. The 60 degrees is fine, but we need our input here. So let's go ahead over to our input action map that we created before, and let's create a turn input here. I'm going to go here. This is actually, we got to make sure that this is set to value, and it's going to be a vector2 value. And then here we will go to XR controller. We're going to go to the right controller this time. Optional controls, primary 2D axis is our thumbstick. So let's go ahead and save that out. And then we can go over to our thing here and just assign that turn there. And with that, let's go ahead and test this out in the editor. All right, we're here in the headset. Let's go ahead and click play here. And here we are. We have our teleport from before. We have our smooth turn is working. It's actually a little bit slow. I thought 60 was a good speed for me, but it seems the turn is working. Now, actually, there is one thing I'm noticing here, and that is a lot, unless I'm perfectly centered, because we're also using this thumbstick for the turning, we're actually turning at the same time as we're trying to teleport. Let's actually fix that and make sure that that is not the case. All right, so first thing I'm going to do here is I'm going to increase the speed here. So that's going to be, let's just say 100 degrees per whatever. And I'm actually going to use this bottom threshold now as our minimum value amount. So let's go ahead in our script here. And I'm actually going to get the absolute axis. And then what we're going to do is we're going to check if the absolute axis is less than m snap turn bottom threshold, then we're just going to get out of here. So now what I'm going to do here is I'm going to change this because this no longer applies to the snap turn. So I'm just going to call this m bottom and m top. By the way, how you get to this special rename thing where it will actually rename, like you'll see here, I renamed it to bottom threshold up here, but it also changed the name down here. That's if you press Control R and then you hit R again with Control still held down. So you press Control RR, so you press it twice. That will rename it everywhere where it's referenced. Something that's very handy. And then I'm actually just going to get rid of these headers because these headers don't really apply. And then I'll move this guy up here. Let's move smooth turn first, and then these are all kind of snap turn adjacent. So now that should make that feel a little bit better. Let's go ahead and test that out. All right, back in the headset, the smooth turn is feeling a little bit better. It's a lot faster. And if I press, we do have this kind of dead zone in the center, but I want it to be a little bit bigger. So let's actually, I'm just gonna hop out of here for a sec. And let's increase that minimum threshold to, this isn't gonna be a big deal for our snap turn either, but let's change this to 0.25, so it's a quarter. And let's hop back in, see how that looks. And that does feel a little bit better. It's a lot easier to not turn. Now, here is the other thing, is we can play around with this all that we want, and you see I am still accidentally hitting it, but the likelihood of somebody wanting to use smooth turn while also using teleport movement is very slim, because usually someone will use teleport movement because they're getting sick, and smooth turning tends to give more people motion sickness than smooth motion will. So the likelihood of somebody actually running into this problem is quite low, but again, you can mitigate it as much as you want. If you have a snap turn only game and you want to offer smooth turning, then you can do things like make sure that you could have the turn axis on the other controller if you wanted, or you could have a larger dead zone, like something that's like 0.5 or whatever, where it's not going to feel weird for the turning. So that's all up to you. You can tweak those values as you want. But anyways, let's go ahead and do snap turning now. All right, let's go ahead and dig into snap turning. So in our snap turn, we're going to need to do something kind of similar that we started out first. I might as well just grab this as well here, but we're gonna need both that rotate axis again and our absolute value of that axis. And the next thing we're gonna do is, because we're kind of doing this threshold thing, because we're kind of creating a instant button event out of a constantly changing value from 0 to 1, we're going to need to use these thresholds and then also have sort of a way of keeping track of whether or not we have used the threshold or not. So I'm going to create a Boolean here called m is snap active. Set that to false by default. And so what we're going to do first is we're going to deal with if we are already pressed, because this is kind of the smallest amount of code. So if snap is already active, so we've already pressed our snap turn and we're wanting to now check for our return below the bottom threshold again. We'll check if the absolute axis is less than bottom threshold. And again, we're using this absolute axis because we want this to work in both directions. And if we're moving the stick to the left, that's going to be a negative value, and the negative, technically it's a greater magnitude value with the negative sign. So we want to just be testing our absolute values here. And then we're going to set snap is snap active to false. So again, we were checking if this is already true. So now we're turning it to false. And then here, we're going to get out of here if snap is active regardless, because we don't want to be doing any more snap turning. Otherwise it will just instantly keep moving you around and around and around and around and around and around in circles. And that will get very dizzying very quickly. Okay, so now outside of this if loop, because we returned, we know that snap is not active. So now we're actually testing for the snap turn being applied in the first place. So again, we're going to take that absolute axis is greater than the top threshold. Or actually, no, sorry, let's do this inversely. So if it's less than the top threshold, we're just going to return. That way we're not doing a lot of nesting. And then, so now we know that is snap active is going to be true, and we're going to actually apply our snap turn amount. So our turn amount is going to be I'm going to do a ternary operator here. It's going to be rotate axis is greater than 0. So this is if we're in the positive direction, so that's going to be to the right, we're going to apply a positive rotation. So that is going to be 1, or I guess m turn snap turn amount, and then the other value is going to be the negative snap turn amount. I'm actually sorry, I don't know why I put these parentheses here. It's not really necessary. And then we're going to do basically the exact same thing. We can just grab it from down here. We're going to apply, again, we're going to be turning around the camera position. So that is done there. We have our turn amount here, and because we called it the same thing, it's all good. So because this one's a little more complicated, I'm going to talk through it one more time now that we have it all kind of written out here. So we get our rotation axis, which is the X axis of our thumbstick. We're going to get the absolute value of that. So it's an always positive version, no matter if it's left or right. This is checking if our snap turn is active. That means we've already turned, but we're still holding the thumbstick. If that's the case, we want to check for our return away from that. So we're going to check if we're below that axis. If that's so, we're going to reset this Boolean so that we can check this stuff again and do another rotation. And then we're going to get out of here because we don't need to deal with anything else if we're already active, because we don't need to be doing snap turns every frame. Okay, so now if snap turn is not already active, so we're at sort of a rest position on the thumbstick, we're going to just get out of here if we're still below our top threshold, because there's no need to apply a rotation if the thumbstick isn't being pressed. Now, if that's not the case and we are actually above or equal to this top threshold, we're going to set the snap turn to active so that we can detect this state again. And then we're going to apply our turn amount based on the direction of the thumbstick, which we could just get from whether or not it's positive or negative. And then from that, we just apply the rotation, same as we did before. So let's go ahead, hop back into Unity and test that out. Just 1 second though, we got to go ahead and change this from smooth turn to snap turn. All right, so we're back in the headset. Let's give the snap turn a try. And it looks like things are working properly. You'll see here, if I hold the thumbstick it down. I don't keep rotating. It's only when I return and then press it again. So that's our bottom threshold, top threshold working. And we can still teleport. Things are working great. Now we do have a bit of a problem, and that is if I step back all the way in my play space to the point where I'm almost seeing my room, okay, and then I teleport, if I'm facing the original direction that I spawned in with, which is looking at this cube, and then I move over to this, let's use the corner as an example, things are great. I am standing in the corner, the offset is working. Now I'll move back here. If I am rotated, and again, you can kind of see I'm in line with this cube here as I'm rotating. I stay in line with it even though I'm further back in the play space. But now if I try and target that same corner, you'll notice that it's way over there. And that is because we were using the local space for our offset calculation for our teleport movement. So now we need to actually take into account our rotation, because now that we've done our own rotation around the camera, the actual local position has changed when we rotate. So we need to go ahead and fix this. So let's go ahead and jump in and fix that. All right, so in order to fix this, we're gonna need to go up to our player teleport. We're gonna need to open that up in Visual Studio, and we're gonna need to scroll down to find our set position. Now, what we were doing before is just getting the camera in the local space, but of course this local position is now not necessarily accurate given the rotation of what's going on. So we're going to do this a little bit differently. The offset is now going to be the m camera dot position minus transform dot position. We're going to set the offset dot y to 0 because we don't care about that offset, and that should go ahead and fix our problem. So let's jump back in and give that a test. All right, so now let's give this a test. I'm going to step back in my play space again all the way to the back, and there's the back of my play space. If I rotate now and then aim for that corner, we'll see that the corner is right below me. So that has been fixed. We can also see that I am rotating around my camera position as well, so that's still working nicely. And so that's pretty much it. And there we have it, smooth and snap turning in VR. If you haven't already, make sure you hit subscribe, hit a like on this video as well. Make sure you stay tuned as well for the next video, which is going to be our smooth movement video. And also, if you're looking for a fun game to play, I have a VR puzzle platformer called Neon Cipher that's available on Steam and MetaQuest, so go ahead and check that out. Links are in the description. And that being said, I'll leave you guys to it. Have fun making games.